Okay, you're going to learn about polynomial functions of higher degree. We've been working with polynomials squared quadratics, right? So now we're going to have exponents that are higher than 2. Okay, got any questions? How to use transformations to sketch graphs of polynomial functions? What is the leading coefficient test and how to use it to determine the end behaviors of graphs of polynomial functions, and how do I find and use zeros of polynomial functions to help sketch the graph. Alright, some nomenclature, meaning names of stuff. Okay, let's talk about some names. There's these 2 points here on my graph with the x-axis. We call those intercepts. We also call those zeros. We have a 0 at 2. And we also have a 0 at 6. We also call them solutions or roots. We have x is equal to 2 and x is equal to 6. Those are just roots or solutions or zeros. Also factors. Factors are what make this parabola. The factors are x minus 2 because 2 is a 0. If I put a 2 in here, that makes a 0. You see the 0. So if I put a 6, 6 minus 6 makes another 0. So we call these factors. And intercepts. Intercepts are places where it crosses the x-axis, 2, 0, and 6, 0. Hope that takes care of nomenclature. So they may be asking one of these 4 things, but they all mean the same thing. All right, odd and even functions. Consider these 2 functions. Whether they're odd or even, we're talking about the exponent. Okay, the exponent here is a 1, so that's considered an odd, and it's going to behave like a line, and this is actually a line. So if this was like a cubed, so it'd still be odd. So the endpoints will still be like this. It'll be up to the right and down to the left. Okay. If it's even, like a squared, it's going to look like a parabola. Endpoints are going to look like a parabola. They're both going to be either going up or they're both going to be going down. Okay? So, all right. So this says that 2x to the 1 power plus 3, that's an odd exponent. And 4x squared plus 1 is an even exponent. That's an even. All right, when we have an odd or even, we're going to look at this as the leading coefficients test. The leading coefficient is the one, it's the coefficient or the number in front of the highest exponent. Okay, so in this case, it's going to be this coefficient, the one in front of the x, the 5th, not the one in front of the x, because this is a bigger exponent. So the negative 6 tells you it's negative. Okay, since it's negative, it's going to go like this. Okay, it's going to look like a negative slope line. Because this is odd, it's either going to they're going to go in opposite directions like a line. All right, so let's see here. If we look at the middle part, we don't care what the middle part is yet. Okay, it's going to do something weird in the middle, so we're just looking at the endpoints. In this case, this is going to go up to the right, down to the left if a is positive. When a is negative, like in this case, it's going to be up to the left and down towards right, like a line with a negative slope. Okay? This is a line with a positive slope. All right, when the exponent is even and a is positive, the endpoint is going to remind you of a parabola where they're both pointing up. And if it's negative, then they're going to be both pointing down like a parabola. And we don't really care what it's doing in the middle. It could be doing something weird in the middle, but that's what we're just looking at, the endpoints. So that's the leading coefficients test. So let's do some examples here. All right, Using the leading coefficients test to describe the right and the left-hand behavior of the graph of each function. Notice this is odd. Okay, since this is odd, that means it's going to look like a line. The endpoint's going to look like a line. That's either going to be a negative slope or positive slope, depending on this here. So the exponent's odd, so the endpoints act like a line. And since a is negative, it's going to look like a line with a negative slope. That means it rises to the left and falls to the right. Rises on the left and falls to the right. Look at this one. We have an even exponent, leading coefficient. That means endpoints act like a parabola. And because the coefficient a is positive, this is a positive 1 in front, that means it's going to act like a parabola that opens up. So both endpoints are going to go up. Up to the left, up to the right. Okay, on this one, this is a 5, so that's odd. So it's going to act like a line. So since it's odd, it's going to act like a line. The endpoint's going to act like a line. And because it's positive, it's going to fall to the left and rise to the right. Okay, I have a couple more here. What about this one? We have the leading coefficient is a 4. I mean, it's the leading term is a 4, this 4 right here, and the leading coefficient is a negative 1. So the exponent is even, so it acts like a parabola, and it's an a, so it's negative, so it's going to fall to the left and fall to the right like a parabola, a negative parabola. Alright, what about this mess here? Alright, so we're looking for the one with the highest exponent. So we're looking at this one here. Okay, so this, if you divide each one of these by 4, then you're going to get rid of this 4 here. But it's an odd, okay, odd, so it acts like a line. And because this is negative, a negative line is going to rise to the left and fall to the right. What about this one here? Okay, the highest exponent's right here. So it's odd, so it's going to act like a line. And it's a negative out in the front. So it's going to rise to the left and fall to the right. Okay, finding all the zeros. A fundamental theorem of algebra tells you that the highest exponent is 3, so there's going to be up to 3 zeros. Okay, it could be 0, 1, 2, or 3 zeros. Alright, so we're going to factor out an x. Okay, so we're going to factor all of these to get all our zeros. Factor out an x, that's the easiest thing to go do from here. And then from this, you have to remember how to factor a trinomial. That factors to x minus 2, x plus 1. So where are my zeros? Well, using the zero product property, I'm going to split this up into 3 different zeros. So I'm going to move these apart and solve these each one for 0. Okay, that means this one's already done. X is equal to 0. What about this one? You add 2 to both sides, and you're going to get x is equal to positive 2. Subtract 1 from both sides, and you get x is equal to negative 1. So these are my 3 zeros. So this is find all zeros. Since we have 3 zeros here and we have a maximum of 3 zeros, we found them all. You try to do this one, okay? Just follow what I did in the last one. Unpause this once you get the answer. Alright, factoring out the x, factor out this trinomial. I get x minus 6 and x minus 6. So I have x is equal to 0 and x equals 6 and x is equal to 6. Normally I would say just write the 6 once, but when we're graphing these, we would need to know how many of the same numbers that we have. So write this as 0, 6, and another 6. Okay, you'll see how important that is in a little bit. And also, you have to know that there's 3 here, so you should find 3. So just leave both of these separately. Okay, find the zeros. Relative extrema. I'm going to skip the relative extrema here. Alright, sketching this. So when we sketch this, we're going to find the zeros. And from what we just did, we know that there's a 0 at 0 and at positive 1. Okay, these are my two zeros. So when we put these 2 points on here, remember that there's 2 zeros, so it's even. What does the leading coefficient test tell me if there's an even number of zeros? If this is going to be x squared. That means it's going to act like a parabola. The endpoints are going to both go up because it's even. And because it's positive, a is positive, positive 1, so that we're going to put these 2 points on here, 0 and 1, and then we're going to make the endpoints go up because this is squared, right? If we distribute the x, we get a squared here. So they both go up, and then we just connect this together, and we have this thing is graphed from this. Okay, right now I'm not going to hold you accountable for how low this is going to go. Just connect them up like that. Okay, let's try this one here. This one's a little more complicated because we have, remember I said to write out all the zeros, so you're going to have 3 zeros here, and then another one that's going to be 2, which makes another 0. So you have 3 zeros and a 2. So you're going to put a point here and a point here, and since we have an even number of zeros, we know that the endpoints go up, and since it's positive, they both go up like that. If a was negative, they would both go down. Okay, and then since this is odd, so we just connect that, and that's how we graph that. Okay, so if we only graph the 0 one time, what do we need to know that there were 3 zeros? Here's a case where you need to know. All right, so you have x squared, so that gives me 2 zeros at 0, and one of them, oops, this should be a 3. That's a typo. Alright, that should be a 3. So that means that we're going to have a 0 here and a 0 here. And because this x times x times x, the exponent is going to be odd and it's positive. What is that going to look like? It's going to go down this way and it's going to go up this way. Alright. But look, I can't connect that, right? If I try to do something like that, look what I did. I made another 0 here. I'm not allowed to do that. So let's back up here, all right? Okay. Let's put out my zeros here, okay? And I know that it goes up this way, it goes down this way. But whenever there's an even number of the same zeros, it doesn't go through. It bounces off, and then it continues through the one that's odd. There's only 1 here, and there's 2 here. So this is even, and this is odd. So that one bounces off that one and goes through the odd one. Okay. All right. Let's try another one. Okay. Okay, look at this. All right. So we have 3 zeros here, 4 ones, a -3, and a -5. Okay. So I have 1, 2, 3. It goes through the 0. It bounces off the 1. And it goes through the -3 and -5. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9. So that tells me that it's going to be 0, 1, -3, and -5. So it's there are going to be 9 numbers, 9 zeros, odd, and it's positive because there's a positive 1 in the front. So it's going to look like that. So how do we draw that? We want to go through the -5, go through the 3, go through the 0, but we have to bounce off the 1 because there's an even number of 1s. So through, and bounce off. So we go through, and bounce off the 1. Okay, let's try one more. See if you can draw this one on your own and unpause it once you tried it. It's okay to get it wrong, but it's not okay not to try it, okay? Alright, so I have a 0, a positive 4, 4 of those, a positive 3, and then 2 negative 2's. So I'm going to put the 0, the 4, the 3, and the negative 2. And there's going to be 8, so, and the negative 3, that's even, and negative, so that means they both go down. Okay, so now I'm going to have to go bounce off the 2, negative 2, go through the 0, go through the 3, and bounce off the 4. So I'm going to go bounce off the negative 2, go through the 0, go through the 3, and bounce off the 4. Okay. Alright, let me go back a little bit. Just make sure that you understand that you're not allowed to do things like, ooh, let me go through here, go through here, go through here, go through here. Yeah, but see, you're not allowed to do that, alright? Or you're also not allowed to go, okay, I have to bounce off the negative 2, so I'm going to bounce off this one and go through here, go through here, and go through here, and go, oh, I need to go back down. I have to go back down this way. Now you created another place where you cross the x-axis. You made another 0 which didn't exist. Okay, you can't do that either. Alright, let me get rid of this line here. That's not supposed to be there. So that's it. Okay, don't forget to do the Google form.